All right, welcome back for people watching the video. If you're in class or on Zoom, you were here all the time. We're starting at 2.3. This is on techniques of differentiation. And if you're tired of dealing with limits like we've done for the last 3 weeks, yay! This is your good day. So, first rule. If f of x has a constant value, c. Then the derivative there. Equals 0. You can see that real quick without writing out the full limit. If you try to do f of x plus h minus f of x over h, and there is no x in it. There's nowhere to put in x plus h, and you just get c minus c over h, which is 0. And you don't even need the limit thing. Top is 0. So derivatives of just anything without a variable is 0. Derivatives of numbers without variables is 0. Next one, first rule that most people learn, well, the one that like is important, most important. The power rule, called the power rule. If f of x equals x to the n, then the derivative of f of x is n times x minus x to the n minus 1 power. Bring the power down, lower it by 1. And we can show that real quick. I don't know how quick it's gonna be, but let's just show it. Now, right before class, I sent out an announcement of a couple links I'm going to show right now. This is called a binomial. That bad boy right there is a binomial. And there are formulas for how to expand it. It follows a simple pattern. If you already know it already, it's pretty cool. It uses Pascal's triangle is probably the easiest way to do it. Some of them use the combination formula, which is a pain in the ass. That's a calculator, but the triangle you can draw by hand. So let me show you guys how we're gonna get x plus h to the n right now. Let me. Oh. Maybe share. Choose where I'm sharing as I'm doing it. There we go. Now I click share. There we go. All right, so we're gonna use this formula here. It's a to the n, and then the first one has an n in front of it. A goes down a power. B shows up, so like b is 0 here, a to the n, b to the 0. Here, a goes down by 1, b goes up by 1, b to 0 goes up to b to the 1. Here, a goes down again, b goes up again. And it keeps going down where the power on a goes down and the power on b goes up. This is a generic formula using, and that's what we're going to use. A simpler way to see it is like doing Pascal's triangle here. You make a little triangle where on the outside, let me see if I can. On the outside, you draw ones, and then going down, you just add the two numbers that are above it together. So 1 plus 1 is 2, 1 plus 2 is 3, 1 plus 3 is 4, 4 plus 6 is 10, 10 plus 10 is 20, 5 plus 10 is 15. You're making the triangle this way, and then like these show, this is the a to the 0, or n equals 0, n equals 1. This diagonal right here, this first diagonal right here, shows what nth power it is. So like if we had a plus b to the nth power, where n equals 6, we're on the line that has a 6 right here. And so the first one you do a to the 6th power, then you lower a by a power, raise b by a power, and these coefficients just start falling into place in front of them. You'll notice a goes 6, 5, 4, 3, 2, 1, 0 on a. And b to the 0 is here. You don't see it because anything to the 0 is 1. B to the 0, b to the 1st, 2nd, 3rd, 4th, 5th, and 6th. Nice simple pattern where a goes down a power, b goes up a power, and the coefficients that go in front come from this triangle. It's handy. You don't need to know how to do this generally in this class, but it will speed up multiplying stuff out for you. But I have links to it in an announcement here.
Do any of the math classes after calculus one use it? Or is it just kind of?
It just speeds up multiplying stuff out. There are points where you may use it again, but if so, it's gonna be a while. And you won't remember this formula. This is like a pain in the ass to remember, but the simple process of how to do it with the triangle is pretty easy. I'm gonna use this formula right now. This is what I'm about to write down. Rather than write down n times n minus 1 to the 2, I'm just gonna say, I'll give it a different number or letter here. Let's go back to our work. So, rewriting that. We have f prime of x, because that's what the left side is, equals limit as h goes to 0. I'm expanding out that first one. That first one was x to the n plus n to the x minus. I'm sorry, oops, or the wrong thing. No, I didn't. Plus n times x to the n minus 1 times h. And then we had like a sub 2 x to the n minus 2 h squared. And we go all the way down where we have like a sub k x to the h to the n minus 1 plus h to the n. That would be an n right there. The two ones on the outside are just ends. Except in. And then. Minus x to the n. So. I'm gonna give myself a lot of room right there. The x to the n and minus x to the n cancel out. And we have limit as h goes to 0. I'm gonna put 1/h, this thing out front. We have n to the x minus 1, n times x to the n minus 1 times h plus a to x to the n minus 2 h squared plus n x h to the n minus 1 plus h to the n right now. And then we're gonna multiply the 1/h in. That goes down to power. That goes down to power, and that goes down to power. All of these have h's in them. This one doesn't. And so that's the only one that's left. F prime of x equals n to the n times x to the n minus 1. Now, remembering the proof isn't essential. This is what you want to know. You want to know the rule. I was just showing that why it works. It's not some magic. No, Jacob. Wakey, wakey. I know the slow drip to the eye, don't tell me you weren't falling on the drifting off. I know that. You know, where the eyes slowly collapse and then they fucking pop open really fast, that's someone fighting sleep. I could bring a squirt gun if you'd like. Yeah, I'll just tag you right in the head. I'll give it to Brianne. She'd probably enjoy the shit out of it too. Get right in the air. You guys ready for more?
I'll take water and I'll pour it in my back a little bit. If I'm sitting like in my house or whatever, I'll just pour like a little bit of water down my back and it'll wake me up.
You know, it's fun, taking an ice cold beverage. Putting it against someone's back of someone's neck without them knowing it, but then going, is this hot? As you say it.
Is this hot?
Yes, it fucks with them. Because cold burns if it's cold enough.
Okay.
And the immediate reaction is, ouch, that is hot. And then you're like, hold it on, and you're like, nope, it's fucking ice cold.
Yeah.
That's the other things that are like just as fun is like. You let out a silent but deadly and then ask, do you smell something burning?
I don't know.
That's a good one, because when someone hears that something's burning. We instinctively sniff for smoke. Because fire is death, fire is danger, it kills. So like we immediately smell the air for smoke. So you just let out one that no one can hear. Good stuff. I can teach you more than that here. Alright, you guys are done with that? Next one. If F is differentiable. And C is a constant. Then. The derivative of f of x. Where. We're doing. Oh, nope, sorry, C times f of x, let's see that. Equals C times d dx of f of x.
Said that was C of F of X.
Yes,
Okay.
C times f of x. Let me rewrite that where it looks a lot cleaner. It's a little easier to read. You can see this if we just say, let's say g of x equals C times f of x. And we'll do the derivative of g. Derivative of g equals derivative of C times f of x plus h. But we're doing the limit thing here, so limit as h goes to 0. G of x plus h minus g of x over h. Equals the limit as h goes to 0. Of C times f of x plus h. Minus C times f of x. Over h. Try not to go too fast. We're gonna factor the C out. And we saw one of our limit rules was the limit of a product means we could do the limit on each product. This is the limit as h goes to 0 of C times the limit as h goes to 0 of f of x plus h minus f of x over h. And recall this is g prime of x. And the first one has no h in it, so it's just c. And that is the definition of f prime of x. Smoke isn't the only one that works. Bacon or like fresh baked chocolate chip cookies. Anything that people like to smell or people are afraid to smell will work. Fear and love of smells is what triggers people to do it. Most people, unless they don't like bacon, most people like the smell of bacon. Cause it, like, bacon's delicious. And like fresh baked cookies, when you use. That's a great, that's why they, when they're selling homes, they bake fucking cookies in the place before an open house. So it smells like fresh baked cookies when you walk in to explore the open house where it's up for sale. Cause it makes people like, oh, this is a nice welcoming environment. People like the smell of fresh baked cookies. You say that when you fart tail. Gotta change it up, you can't just do the smoke one every time. Alright, so let's apply this. Let's say we got an example. F of x equals, let's go with 5x cubed. And we're gonna find f prime of x. The slow way of doing this is writing this shit out like this. And then using that last rule we did, pulling the 5 out. And then taking the derivative of what's inside, we bring the power down in front. We lower the power by 1. And we get 5 times 3 is 15x squared. A better, faster approach when you're doing it. Rather than writing out like these middle steps, just bring the power down. Bring the power down and multiply it. Just give you guys one. What is f prime of x?
32x5.
Yeah, give everybody a chance.
Looked at it.
Have you written it down?
Fair enough.
It's too big. How did you say that again?
42x to the fifth, or 42x5, I said 42x5, but
I was gonna say, don't say x5. As long as you know it's x to the fifth, that's fine. There are people that don't, they'll just say x5 and don't realize like. That's not like. You're gonna just confuse the shit out of people. So. Bring the power down, lower the power by 1. 42 times x to the fifth power. Ready for the next rule? What, Tyler, you don't like this? Why are you smiling so much?
My brain is dead.
Your brain is dead?
I get like 4 hours of sleep.
That's not very much. You shouldn't stay up so late.
Well, you know, insomnia is a bitch.
Yeah, it is. There's lots of things that'll make you tired though. There's some good drugs out there. I take them every night. Sleep medication. I don't know what you guys were thinking I was about to say. Sleeping pill or melatonin. Melatonin's at like 5 MCGs or MGs, I don't remember what it is. But it just fucking helps you go to sleep.
Sleep, depends on what you take.
Don't overdo melatonin.
No, I can't do that.
Don't overdo anything. Everything in excess will kill you, including water.
Okay.
Like we require water for life, it will kill you in excess. So will oxygen. I just pump you full of oxygen until your lungs can't fucking take it anymore and burst.
Thanks.
That one's unlikely to happen on your own. Someone has to do it to you. You can't injure yourself by drinking too much fucking water though.
But
Dude,
your
I read
lungs.
about this kid who's like friends staring, and then like when his mom picked him up, he was blue. So he took him to the
From what?
water.
What?
Like,
Wow.
he dared him to drink a ton of water and he just didn't.
Did he survive?
I think so.
And you can drink a lot of water in a day. Like I've had a gallon of water in a day before.
Yeah,
And that,
can't drink it all at once.
yeah, you don't drink it all at once. It's just kind of hard to do. Your stomach won't hold a gallon of water all at once. I won't tell you why I drink a gallon of water in a day. It's not important.
Do you remember that competition in the 2000s for the week or no? The radio, it was in the news, that radio competition where the person that drank the most water on the radio show won a Nintendo Wii, but the person that won it died from it.
Wow.
Wonder if that's true.
That's a good day to be second place.
Just know that.
You're a sick fuck. That's just wrong. Alright, next theorem. If F and G are differentiable. Then so are their sum and difference. The derivative with respect to x of f of x plus g of x. Or we can do f of x minus g of x equals the derivative of f of x plus or minus the derivative of g of x. And I've been saying a lot, we say the derivative of f of x. Is short notation. For. Derivative. Of f of x. With respect to x. This is actually pretty important. Later on, you learn to do it with multiple variables, so you can only, like in Calc 3. You'll take derivative with different variables in there, and if you only do x.
Or is that where you use, I don't know if you know the capital T of X?
That's a common one
Yeah.
with the subscript that shows what letter you're doing. I'll come back to this red line in a second. Like give you an example real quick. But Proof here. We'll do the limit, we'll just do the plus one. Limit is h goes to 0, f of x plus h plus g of x plus h minus f of x plus g of x all over h. And we separate it up. We'll put the f of x's together. And we'll put the g of x's together. And we know limits can go to each thing individually. This first one is f prime of x. And the second one is g prime of x. So a fun one on this thing. If we did the derivative with respect to t of f of x. This has no t in it. So it's like a constant. That equals 0. In fact, it's when you. I know I told you guys that in like Friday Night Lab, we do the derivative beat every semester. Last year, there was a couple students that are doing really well. I think that in fall. I did the final problem. We did some super giant fucked up function. X is all over the fucking place, and we said derivative with respect to t. And some people did not recognize that this was with respect to the wrong letter, and they're trying to work out this god tremendously awful thing. And another student looked at it, sat back, looked at it. Hesitated, and then just wrote 0. Fucking saw it right away. The other students were. Did it as like a tiebreaker for the first place. The dirty trick. So that's why when I say derivative of f of x, for now, just note, it's with respect to x. Keep in mind that's what it means. I'll try to say it every once in a while. Let's find dy dx. Let's give you guys an example. Doing this something. Find if y equals 3x squared minus 4x plus 8. Find dy dx. Now, the slow way of doing this. When you take the derivative of this, doing the derivative of each one. This is technically what's happening. By that rule we had up there. So here we bring the power down and lower the power by 1. Here we bring the power down, that's a 1. We do 1 minus 1 on that one, and the derivative of a constant is 0. So dy dx equals 6x minus 4. With a little practice, you can blindingly quick jump to that. As you practice it and get more confident, it's super quick, you don't even stop to think about the shit that's what's going on in the middle. But we're actually applying this shit kind of thing. Let's take a 10-minute break. And pause this. There's a question during break, like what happened between here and here? So I pointed out that this has a invisible 1 on it. And so like what we're doing is we subtract the power. And so we technically have x to the 0 here and x to the 1 there, but x to the 0 is 1. And that's how we get 6x minus 4. Got a little bit more going on in this section. Not a whole lot. So another thing that we're gonna look at what point does f of x equals x cubed minus 3x plus 4 have a horizontal tangent line? So what is the slope of a horizontal line?
0.
It's 0, right? And recall f prime of x gives us the slope of a tangent line. So what this question boils down to is where does f prime of x equal 0? We're gonna use this a lot later on. This idea of finding where the derivatives equal 0. Like if I have some function like this. F prime of x equals 0 here. 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 And you see why that would be useful? You're trying to graph a function. You can find the points where the function changes direction. Stops going up and down. That's why this becomes so important. That's pretty cool. So what is the derivative of f prime of x? F prime of x equals 3x squared minus 3x to the 0, which is 3x squared minus 3. We wanna know where that equals 0, so we're gonna set it equals 0. And we're not gonna guess answers, we know how to do this, this is an algebra problem. Add 3 to both sides. We get 3x² equals 3. Divide both sides by 3. We get x² equals 1. Take the square root, we get plus or minus 1. Another way to do that is factor out the 3 and divide by 3. And factor. Lots of ways to get this problem done. Just to refresh your algebra a little bit. Wasn't that fun? Most of them are like, no, that's not fun. But I hope you can see where it's gonna be useful later on. We will use it. We're gonna find where graphs change direction and shit like that later on. Alright, you guys ready for the last thing in 2.3? Nope, computer's all right, don't rush. Don't rush the gun here, Dave. Slow down. Take it easy. Slow ride. Alright. Anyone need this longer? Alright, final thing, higher derivatives.
Is it still 2.3?
Yep.
Okay.
2.3, still on 2.3. So the first derivative is f prime of x or d dx of f or df dx. Second derivative has a couple ways of showing it. What we're really doing is we're taking the derivative of df dx. And so when we write this as d2f over dx squared. Another way is doing d dx of f prime. And we also write it as f double prime. In some books, you'll see d squared f of x or d squared with an x down here of f of x, where this denotes with respect to x. Since we often say y equals f of x, we'll have y prime equals f prime of x and y double prime equals f double prime of x. So you'll see those also. So find the first four derivatives of. F of x equals x cubed. Plus 5x² minus 2x. And remember, this is the same thing as y. So. We do the first derivative, y prime. Equals f prime of x. Remember, we bring the power down, we lower it by 1. Bring the power down, lower it by 1. Bring the power down, lower it by 1. This is 3x² plus 10x minus 2. When we do y double prime or f double prime of x, we're really taking the derivative of this last step. So 2 times 3 x to the 1 plus 10 is 6x plus 10. What would the third derivative be? Just 6, right? We're doing d dx of that 6x plus 10. It's just 6. Now, on the fourth one, they stopped doing this apostrophe thing because it gets kind of annoying. At some point, you're like, I don't want to count the fucking apostrophes. So when they do the fourth derivative, they'll do it like this. They'll put a 4 like that. And if you do it on this one, this tends to, I've never seen this. I haven't seen this. But maybe that's how they do it. I've seen this one. This for sure. This is correct. Notation. We're doing the derivative of a constant, which is 0. Wasn't that fun?